Hello student, welcome to my channel Learn Physics. Today I will be discussing the one short video of rotational dynamics. Now today's discussions are center of mass and motion of center of mass and 6 numerical related to this. Then center of gravity and difference between center of gravity and center of mass and one ncert numerical related to center of gravity. Then vector product and its different characteristics and 3 ncert numerical related to this. And then explanation of v vector equal to omega vector cross r vector and one important ncert numerical related to this. Then torque and 4 numerical related to it, angular momentum, 6 numerical related to it, conservation of angular momentum, then the equilibrium of a rigid body, moment of inertia, perpendicular and parallel axis theorem, and 5 numerical related to it, and kinematics of rotational motion, dynamics of rotational motion, and related numerical of this is 4 plus 2, that is the 6. Then pure rolling, motion in inclined plane, and kinetic energy during rolling. So this discussion will be very important for you. This discussion help you to score better mark in NEET, main and advanced. Please like, share and comment on this, and if you are new, please subscribe my channel to get the new concept of physics. Now first of all, a rigid body. The distance between any two particles of a body is same, then body is called a rigid body. Now center of mass. Suppose look at this is a body. The center of mass of a body is a point where whole mass of the body is supposed to be concentrated. Now center of mass is a point if force acting on it, only linear motion is produced. No rotational motion is produced. Now we have to calculate the position of center of mass. Now to discuss the position, now to obtain the center of mass, we have to use the formula, the moment of mass. Look at this, suppose this is a rigid body. It consists of large number of particles having masses m1 at a distance r1 from origin, mass m2 at a distance r2 from the origin, mass m3 at a distance r3 from the origin, mass mn at a distance rn from the origin, and suppose the distance of center of mass consider rcm. Okay, from the principle of moment of mass, the moment of mass of cm, the moment of mass of cm is equal to sum of moment of mass mom of all particles in the body. Okay, so look at this, the moment of mass of cm, this is the m1 plus m2 plus m3 plus plus mn into this is the rcm. Okay, this equal to moment of mass m1, this is the m1r1, moment of mass of m2 is m2r2, moment of mass m3 is m3r3 plus plus mnrn. Okay, so look at this, here rcm is equal to summation of moment of mass divided by summation of mass. Look at this, summation of moment of mass divided by summation of mass. Okay, now with respect to x-axis, look at this, xcm becomes, look at this is the mx by sigma m. In the same way, ycm is equal to sigma my divided by sigma m, and zcm, look at this, zcm is sigma mz divided by sigma m. Now these formulas are formula of discrete particle. Now for continuous distribution of mass, the xcm becomes, look at this, the integration of x dm divided by integration dm. Okay, and in the same way, look at this, ycm is equal to integration of y dm divided by integration dm. zcm, look at this is the integration of z dm divided by dm. Okay, understood? Now motion of center of mass. Now velocity of center of mass, look at this is the sigma mv divided by this is the sigma m. In the same way, acceleration of center of mass, this is the sigma ma by sigma m. Okay, understood? Now I will be solving 6 numerical of center of mass and motion of center of mass. This numerical helps you immensely in your NEET, main and advanced examination. Please like, share and comment on the video. Okay, now let's start. Look at this, masses 100 gram, 150 gram and 200 gram are placed at the vertices of a triangle of side 0.5 meter. We have to calculate the center of mass with respect to this point. Look at this point is taken as origin. So coordinate of it is, look at this is the 0, 0. And coordinate of it is, look at this is the 0.5, 0. And look at this, the coordinate of this point, look at this is the 0.25 and this is the height. So this is the root 3 by 2 into side 0.5. So look at this is the 0.25 comma 0.25 root 3. Okay, now we have to calculate xcm and ycm. Now what is the formula of xcm? Look at this, xcm is equal to m1x1 plus m2x2 plus m3x3. So look at this is the 100 into 0 plus 150 into 0.5 plus, look at this is the 200 into 0.25 whole divided by this is the 100 plus 150 plus 200. Look at this is the 0, this is the 75 and this is the 50 whole divided by 450. So look at this is the 125 divided by 450, this is the 5 by 18. Okay, look at this, ycm is equal to, look at this 100 into 0 plus 150 into 0 plus 0.25 into root 3 into 200 divided by, look at this is the 450. So here look at this is the 50 into root 3 divided by 450. So look at this is the root 3 divided by 9. Okay, so center of mass is this and this. Therefore xcm comma ycm is equal to the xcm 5 by 18 and ycm is the root 3 divided by 9. Okay, look at this is the triangular lamina. We have to calculate the center of mass of this lamina. Look at this, we know the intersection of the 3 median is the position of the center of mass of the lamina. So look at this position is the center of mass of the lamina. Look at this, 4 uniform body, this is the sphere, this is the cylinder, this is the ring and this is a cube. We have to calculate the center of mass of this body. Now the center of mass for a homogeneous body is at its geometrical center. So look at this, the geometrical center of the sphere is the center of the sphere. The geometrical center of a cylinder is the middle point of height, okay, and center of the ring, and finally the center of the cube, that is point of intersection between the two diagonal, is the center of mass. Okay. Next question, will center of mass may remain outside the body? Yes. Look at this, here center of mass remain outside the body. Now in HCl molecule, the hydrogen atom and chlorine atom are separated by a distance of 1.27 angstrom. Now we have to calculate the center of mass of HCl molecule from the hydrogen atom. Now suppose this distance be xcm, okay. Now look at this, so here xcm is equal to 0 into m plus 1.27 into 35.5 m, because the mass of chlorine atom is 35.5 times heavier than the hydrogen atom. So this is the m1 plus m2, so m plus 35.5 m, okay. So look at this, this becomes 1.24 angstrom, okay. Now next, now question is, if the boy runs on the trolley or stand up on the trolley, what will be the velocity? As there is no external force acting on the trolley child system, so velocity remains same, therefore velocity becomes v, okay. Now a body of mass same is projected with 40√2 meter per second at an angle 45 degree with the horizontal. At the top point of the trajectory, the particle breaks into two equal parts. One part falls freely at this point. Find the position of second part from the point of projection. Okay. Now look at this. If there is no breaking takes place, so the particle reaches this point. Look at this, as one part falls at this point, the other part reaches a point in which the center of mass of this and this fragment remains at this position. As mass equal, so this distance equal to this distance. If this is r by 2, so this also r by 2. So distance from this particle from this position r by 2 plus r by 2 plus r by 2. So this is the 3r by 2. So look at this, r dash equals to 3 by 2 r. Look at this, this is the 3 by 2, r is the u square, this is the sine square 90 degree divided by g. So look at this, this is the 3 into 40√2 whole square into 1 divided by 2 into 10. So look at this, this is the 3 into 1600 into 2 divided by 2 into 10. Look at this, this cancel out, this cancel out. So this is the 480 meter from the point of projection, okay. Next, now center of gravity. Suppose this is a rigid body, it consists of large number of particles. So all the particles are attracted by the earth towards its center. So these forces must be parallel. Now the resultant of these parallel forces acting at a certain point, this point is called center of gravity, okay. So center of gravity means the point where weight of the body is acting. Now for a large body, we can't get parallel forces among the particles in it. So center of gravity is not obtained in these large bodies such as Himalaya mountain, and center of gravity is not obtained for a body of weightless condition. Okay, now from this discussion, we differentiate between center of mass and center of gravity. Now center of mass of a body is a point where whole mass of a body is supposed to be concentrated, or only linear motion is produced. Now center of gravity is the point where weight of the body is acting. Now center of mass and center of gravity of a small body becomes identical, but for large bodies center of mass is obtained but center of gravity is not obtained. Now center of mass present for all bodies, but center of gravity is not present for a body is in weightlessness condition, okay. Now a numerical. Suppose this is a body. If some portion of the body is cut from here, now we have to calculate center of gravity or center of mass of the remaining portion. The formula is, look at this, suppose this is the xcm or xcg. This is the m1 x1 minus m2 x2 divided by m1 minus m2, where m1 is the mass of the whole portion, m2 is the mass of the cut portion, x1 is the cm or cg of the whole portion, x2 is the cg of the cut portion. Okay, now a numerical related to this. Now look at this. This is a disk of radius capital R. A smaller disk of radius r by 2 is cut from here such that it touches the center and periphery. We have to calculate the center of mass of the remaining portion. Now first of all we have to calculate the total mass and mass of the remaining portion, then center of this portion. Now look at this, mass of the whole portion m1 is equal to, this is the pi r square into sigma, where sigma is the mass per unit area. Now m2 is the, look at this is the pi r by 2 whole square into sigma. So look at this, this is the 1 by 4 pi r square sigma. So look at this, this is the m1 by 4. Now suppose this is the origin. So cm of the whole portion x1 is equal to 0. So cm of the cut portion obviously r by 2. So this is the x2 equals to r by 2. Now, so center of mass of the remaining portion, look at this, this is the m1 x1 minus m2 x2 divided by m1 minus m2. Now we have to put these values. So look at this, this is the m1 into 0 minus this is the m1 by 4 into r by 2, and here this is the m1 minus m1 by 4. So look at this, this is the m1 r divided by 8 whole divided by, this is the 3 m1 by 4. From here look at this, this is the minus r by 6. So center of gravity shifted from this position to this position because it is negative. Okay, next. Now vector product, a vector cross b vector equal to modulus of a vector into modulus of b vector into sin theta into n cap. Now from figure look at this, this is the a vector and this is the b vector. Look at this, and theta is the angle between them, and look at this here, perpendicular b is the b sin theta. Okay, now where theta is the angle between the two vector and n cap is a vector perpendicular to the plane containing a vector and b vector. So from here a cross b is perpendicular to a cross b is perpendicular to b, a cross b is perpendicular to a vector plus b vector, a vector plus b vector perpendicular to a vector minus b vector. Okay, now geometrical significance. If we complete a parallelogram, look at this here, this is a parallelogram. So look at this, a into b sin theta is the area of parallelogram. Therefore a cross b represents the vector area of parallelogram having two adjacent sides as a vector and b vector. Special cases, when theta equal to 0 degree. If theta 0 degree, look at this, a vector cross b vector, this equal to 0. So look at this, I cross I equal to j cross j equal to k cross k, this equal to 0. Okay, now when theta equal to 90 degree, when theta equal to 90 degree, then a vector cross b vector, this equal to ab n cap. So look at this, look at this, if this is the I, this is the j and this is the k. Okay, so look at this, I cross j equal to k, j cross k, I, k cross I equal to j. So look at this, I cross j equal to k, here j cross k, this equal to I, and k cross I, this equal to j. Okay, now b cross a, Look at this, A cross B represents the direction, this direction. Look at this, A cross B, this direction. Now B cross A, look at this, B cross A, inward direction. So here A cross B equal to negative sign of B cross A. So cross product is anti-commutative. Therefore angle between A cross B and B cross A is 180 degree. Okay. Now scalar triple product. Look at this. Here A cross B is equal to AB sin theta, and this is the n cap. Okay, dot C vector. Now theta is the angle between A vector and B vector, and n cap is the vector normal to the A vector and B vector. So look at this, here AB, this is the sin theta, this is the sin theta into C into 1 into C into cos phi. Phi is the angle between unit vector n cap and C vector. Now special cases. Look at this, when A vector, B vector and C vector are coplanar, A cross B is normal to the plane containing A and B. Therefore A cross B is also perpendicular to C. Therefore A cross B dot C equal to 0. This is known as the condition of coplanarity. Now look at this, B vector cross C vector represents the area of parallelogram having two adjacent sides as B vector and C vector. Now look at this, its direction is directed along this direction. Now A vector dot B vector cross C vector, that is scalar triple product, represents the volume of a parallelepiped having three adjacent sides are A vector, B vector and C vector. So look at this, the scalar triple product of A vector dot B cross C represents the volume of a parallelepiped having three adjacent sides as A vector, B vector and C vector. Okay, understood? Now next. Now ncert 7.4. A cross B represents the area of parallelogram A. Now A cross B represents the vector area of parallelogram M N O P. Now area of these two parallelogram is equal to area of this triangle plus area of this triangle. Therefore 2 into area of triangle M N O is equal to A vector cross B vector. So look at this, the area of triangle M N O is equal to half of A vector cross B vector. Okay, understood? Now next. Now example 7.4. Here A vector and B vector are given. We have to calculate A vector dot B vector and A vector cross B vector. Now A vector dot B vector, look at this, the coefficient of I into coefficient of I. So this is the minus 6. Coefficient of J into coefficient of J. So this is the minus 4. And coefficient of K into coefficient of K. So this is the minus 15. So this is the minus 25. Okay. Now A cross B is equal to, look at this, this is the I cap, J cap, K cap, and here coefficient of this is the 3, minus 4 and 5, this is the minus 2, 1, minus 3. Now look at this, here I into, look at this, the column of I and column of J. Now here column of I and row of J are omitted. So look at this is the 12 minus 5, this is the 12 minus 5 minus J cap. Look at this, the column of J and row of J are omitted. So look at this is the minus 9 plus 10. Okay, now this is the K cap. Here column of K and row of, here column of K and row of K are omitted. So look at this is the 1 minus, now this is the 3 minus 8. Okay, so this is the 7 I cap minus J cap minus 5 K cap is the cross product of A vector and B vector. Okay, now next. From the figure, the relation between R vector, now the relation between B vector, omega vector and R vector is given as v vector equal to, this is the omega vector cross r vector. Okay, for clockwise rotation, angular velocity is directed inwardly. Now again angular velocity can be written as d theta by dt. Again angular acceleration alpha also can be written as d omega by dt. Okay, suppose mass m is at a point p, OP equal to r. Now the torque tau vector is equal to r vector cross f vector. Okay, so torque is normal to the plane containing r vector and f vector. For a anti-clockwise rotation, tau directed outwardly, and for clockwise rotation it is directed inwardly. Now we have to calculate the magnitude of torque. Now look at this line is produced, a perpendicular is drawn here. So look at this, if this angle is theta, so look at this is the small r sin theta. Now perpendicular distance small r sin theta is taken as capital R. So look at this, from here tau equal to f r sin theta. Now f r sin theta is equal to normal distance f into r. Now from Newton's second law of motion, force equal to mass into acceleration. So tau equal to mass into acceleration into perpendicular distance. Now here m, this is the r alpha into r. So this is the m r square alpha. Now m r square is the moment of inertia of the particle about the point O. Now moment of inertia I is the product of mass of the particle and square of distance from the axis of rotation or the fixed point. Now torque has three relation, tau equals to I alpha, now tau equals to force into perpendicular distance, this, and tau vector is equal to r vector cross f vector. Okay, now angular momentum. The moment of linear momentum is called angular momentum. Suppose a particle m moves with velocity in this direction. The particle m is at a point P from O. So look at this, the angular momentum L vector is equal to r vector cross p vector, where p is the linear momentum, p equal to mass into velocity. So angular momentum is also perpendicular to the plane containing radius vector and momentum vector. Now look at this, here L equals to, this is the P r sin theta. Now r sin theta is equal to capital R. So this is the P into capital R. Now this is the mass into velocity into R. So look at this is the m, v equal to omega into r into r. So look at this is the m r square omega. Now m r square is the moment of inertia and this is the omega equal to L. So look at this, as torque, the angular momentum also has three relation. This is L equals to I into omega, here L equals to mvr, and here L vector equal to r vector cross p vector. Okay, now if we differentiate this dl by dt, we get, look at this, I d omega by dt. Now d omega by dt is the angular acceleration. So look at this is the I alpha. Now I alpha is equal to torque tau. So this is the torque. Therefore rate of change of angular momentum with respect to time is equal to torque. Okay, now look at this ncert. Now ncert example 7.5. Here position vector of force acting is given. We have to calculate torque about origin. Now torque about origin, tau vector is equal to r vector cross f vector. So look at this, here I cap, j cap, k cap, and this is the 1 minus 1 1, and this is 7 3 minus 5. Okay, now look at this, here I. Look at this, here row of I and column of I are omitted, so we get this. So this is the 5 minus 3 minus j. Look at this, column of j and column column of j and row of j are omitted. So look at this, this is the minus 5 minus 7 and plus k cap. Look at this, column of k and row of k are omitted. So look at this, this is the 3 plus 7. So here tau equal to 2i cap plus 12j cap plus 10k cap. Okay, understood? Now next, look at this, a particle moves along this line with velocity v. We have to calculate the angular momentum of the particle about any fixed point, and this angular momentum is constant. Look at this, suppose look at this, a perpendicular distance is drawn on the velocity vector. So look at this, this is the perpendicular distance, this is the r vector. So look at this, the angular momentum mv into perpendicular distance. Now what is the direction? Direction is the, this is the r vector and this is the v vector, so it is inward, therefore it is directed in inward direction. Okay, and angular momentum is constant. Now look at this, ncert is 7.6. here position vector and linear momentum vector are given. We have to calculate the angular momentum along x, y and z axis. Now look at this, the angular momentum along x axis is lx, along y axis is ly, and along z axis is lz k cap. So this equal to, this is the cross product of position vector and momentum vector. So look at this, this is the x, y, z, and this is the px, this is the py, and this is the pz. Okay, now look at this, here I, this and this are omitted. So look at this, ypz minus zpy. Okay, minus j cap. Look at this, this and this are omitted. So here xpz minus zpx plus k cap. Look at this column and this are omitted. So look at this, this is the x into py minus y into px. So now comparing this and this, we can get, look at this, this is the lx equals to ypz minus zpy. Okay, now ly, this equal to, this is the zpx minus xpz, and this is the lz, this equal to, look at this, now look at this, this is the xpy minus ypx. Okay, now if the particle moves in xy plane, the z equal to 0 and velocity in the direction of z component is also 0, therefore pz is 0. If z equal to 0 and pz equal to 0, if we put here, look at this, look at this, this is the 0. Okay, now look at this, here pz z, this also 0 and only remain here. So angular momentum only along z axis, so angular momentum becomes this as the particle moves along xy plane. Okay, understood? Now next, now two particles moves in two parallel straight line separated by the distance d with velocity v in opposite direction. Now we have to calculate the angular momentum about the point O. Now perpendicular distance of O from this line is y. So perpendicular distance of this line from O is y plus d. Now look at this, the angular momentum of this particle about this point is equal to L1 equal to, this is mv into y. What is the direction? Look at this. Look at this, this is the r vector and this is the v vector, so it is directed inward, so this is the cross. Now angular momentum of this particle, look at this, this is the r vector and v, and direction of v along this direction, so this is the r vector and v vector this direction, so this is the outward. So angular momentum of this particle is mv into y plus d and this is the directed outward. Now this is the inward and this is the outward. So net angular momentum L equals to, this is the L2 minus L1. So this is the mv into d. Okay, understood? Now next, now conservation of angular momentum. we know that the torque is the rate of change of angular momentum, that is tau equal to, this is the dl by dt. Now we know L equal to omega. Now we know L equal to I omega. So look at this, tau equals to, this is the d dt of I omega. Okay, now if external torque acting on a system is 0, then look at this, 0 equal to, this is the d of I omega divided by dt. So look at this, d of I omega is equal to 0. So I omega equal to constant. Therefore I1 omega 1 equal to I2 omega 2. If there is no external torque acting on a system of particle, then their angular momentum are conserved. That is, when moment of inertia decreases, angular velocity more. When moment of inertia increases, angular velocity less. Understood? Now next. Now ncert 1.73. A boy stretched in hand and stayed on a turntable and revolves with angular velocity of 40 rpm. Now if he folds his hand such that its moment of inertia decreases to 2 by 5 of initial value, what will be the final angular velocity? Now we have to prove the final kinetic energy greater than initial kinetic energy. Now look at this, as there is no external torque acting on the turntable plus child system, so we can get I1 omega 1 equal to I2 omega 2. So look at this is the I into 40 equal to, this is the 2 by 5I into, this is the omega 2. So here omega 2 is equal to 100. Okay. Now kinetic energy. Look at this, the kinetic energy, this is the half I2 omega 2 square and this is the half I1 omega 1 square. So look at this is the I2 by I1 into omega 2 by omega 1 whole square. Look at this, I2 by I, look at this I2 by I1 equal to 2 by 5, and again omega 2 by omega 1, this is the 100 by 40 whole square. So look at this is the 2 by 5 and this is the 25 by 4, so this is the 5 by 2. So final kinetic energy is 5 by 2 times of initial kinetic energy. What is the cause of increase of kinetic energy? Look at this, when the child folds his hand, the work done in folding the hand is converted into kinetic energy. Okay, now a person standing on a turntable by keeping two 5 kg weight at its two hand. Now he folds his hand from 90 centimeter to 20 centimeter. Find the new angular velocity if initial angular velocity is 30 rpm. The moment of inertia of the person and turntable system is 7.6 kg meter square. Now the moment of inertia I1, look at this, the moment of inertia of the person and turntable system plus moment of inertia of two 5 kg mass. So this is the 2 into 5 into 0.9 square, because initially the 5 kg mass are at a distance of 90 centimeter. Now final moment of inertia, look at this, 7.6 plus 2 into 5 into 0.2 whole square, because final distance is 20 centimeter and this becomes 8. Okay, omega 1 is 30 rpm, we have to calculate omega 2. Now look at this, here I1 omega 1 equals to I2 omega 2, as there is no external torque acting on the system. So look at this, here 15.7 into 30, and this is the I2 is the 8 into omega 2. So look at this, omega 2 equal to 15.7 by 8 into 30. Look at this is almost 2. So final velocity is almost 60. Now look at this, the initial kinetic energy is half I1 omega 1 square. Final kinetic energy half I2 omega 2 square, as angular velocity is almost double than that of the initial. So final kinetic energy is more than the initial kinetic energy. So kinetic energy is not conserved. Okay. Now next. Now two disks have moment of inertia I1 and I2 are rotating with angular velocity omega 1 and omega 2 with their respective axes. Now they are brought in contact. Find the final angular velocity and loss of kinetic energy. Now, as there is no external force acting on the system, so angular momentum is conserved. So initial angular momentum, this is the I1 omega 1 plus I2 omega 2. Okay, and final angular momentum, look at this, I1 plus I2 into omega. We have to calculate the omega. So look at this, omega equal to, this is the I1 omega 1 plus I2 omega 2 divided by, this is the I1 plus I2. Okay, now loss of kinetic energy. Loss of kinetic energy means initial kinetic energy minus final kinetic energy. So look at this, delta Ke is equal to half, this is the I1 omega 1 square plus half I2 omega 2 square minus half into I1 plus I2 into omega square. If we put the value of omega, we can get, look at this, this is the half I1 omega 1 square plus half I2 omega 2 square minus half, this is the I1 plus I2 into, look at this, here I1 omega 1 plus, here I1 omega 1 plus I2 omega 2 divided by I1 plus I2, this is whole square. So we get, look at this, this is the half common. Now look at this, this is the I1 omega 1 square plus I2 omega 2 square minus, look at this, this is the I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. If we multiply this with this, we can get, look at this, 1 by 2 into, this is the I1 plus I2, and look at this into this, so this is the I1 square omega 1 square plus I1 I2 omega 2 square. Now this is again I1 I2 omega 1 square. So here I1 I2 omega 1 square plus I2 square omega 2 square, and here look at this, here minus I1 square omega 1 square minus I2 square omega 2 square minus 2 I1 I2 omega 1 omega 2. Okay, now look at this cancel out, look at this cancel out. So we finally get, look at this, half, this is the I1 I2 by I1 plus I2 into omega 1 minus omega 2 whole square. Okay, understood? Now next, now a rotational equilibrium. A body is said to be in rotational equilibrium if the body has no linear acceleration as well as angular acceleration, that is a equal to 0 and alpha equal to 0. Now conditions of rotational equilibrium, as a equal to 0, so vector sum of the forces acting on the body is equal to 0, and the algebraic sum of torque is 0 as angular acceleration is 0. Now The coplanar forces may be resolved along x and y component. So from this condition we can write sigma fx equals to 0 and sigma fy equal to 0. So these are the conditions of rotational equilibrium. Okay, now we solve some numerical related to this. This numerical will be extremely helpful for you. Please like, comment and share the video. Okay, now look at this example 7.8. Look at this. AF is the uniform rod of length 70 cm. Two knife edges at B and E. AB equal to EF is equal to 10 cm. Weight of the rod is 4 kg and a load of 6 kg is placed at the point C, which is at a distance 30 cm from one end. So from the figure, look at this. AB, look at this. AB equal to EF equal to 0.1 meter. AC, look at this. This is the 30 centimeter, that is 0.3 meter. Therefore BC equal to 0.2 meter. BD is equal to, look at this is the 35, this is the 10, so this is the 25, so this is the 0.25 meter. And BE, look at this, 70 minus 10 minus 10, 50, so this is the 0.5 meter. Now considering the forces along y-axis, so sigma Fy, this equal to 0, therefore R1 plus R2 minus 60 minus 40 equal to 0, therefore R1 plus R2, this equal to 100. This is equation number 1. Okay, now considering torque with respect to the point B. So look at this, the force R1 does not produce torque. Therefore look at this, here 60 into BC plus 40 into BD minus R2 into B. Okay, this equal to 0. Because this force and this force produces produce clockwise torque and this produce anti-clockwise torque. So clockwise torque minus anti-clockwise torque is equal to 0. So look at this. This is the 60 into BC. Look at this. 60 into BC equal to 0.2 plus 40 into BD is 0.25. This is equals to R2 into B, that is 0.5. Okay. Now look at this. This into this. So this is the 12. Now this into this. So this is the 10. This equal to R2 into 0.5. Therefore R2 equal to, this is the 44. Okay. So R2 equal to 44 Newton. Therefore R1 is equal to 44. Therefore R1 plus 44 equal to 100. So R1 is equal to 56. Therefore R1 equal to 56 Newton and R2 equal to 44 Newton. Understood? Next. Now a ladder AB of length 3 meter rests on a wall such that the lower end of the ladder is at a distance 1 meter from the wall. So look at this, here OA equal to 1 meter. As length of the ladder is 3 meter, so look at this, this is the hypotenuse, this is the base, so OB equal to, so this is the root under of 3 square minus 1 square, so this is the 2 root 2. Okay, the weight of the ladder is 20 kg, that is 200 Newton. We have to calculate the reaction force N2 of the wall and the reaction force of ground. Now reaction force of ground, that is the resultant force of normal reaction and force of friction. As the tendency of motion at the lower end of the ladder is away from the wall, so force of friction is towards the wall. Okay, now considering the forces along x-axis, look at this, sigma fx is equal to 0. Now this is the f1 and this is the n2. So f1 minus n2, this equal to 0. So f1 equal to n2. This is equation number 1. Now considering forces along y-axis, look at this, this is the n1 and this is the 200 Newton. So look at this, n1 minus 200 equal to 0. So n1 equal to 200 Newton is the equation number 2. Now considering torque about A, look at this. Look at this here, 200 Newton into AC minus this is the N2 into this is the 2 root 2, that is OB. So look at this here, 200 AC means this is the 0.5 minus N2 into 2 root 2 into 2 root 2 equal to 0. Therefore n2 equals to, this is the 100 divided by 2 root 2, that is 25 root 2. Okay, understood? Therefore look at this, this is the 25 into 1.4, so this is the 35 Newton. So normal reaction of the wall, look at this, n2 equals to 35 Newton. Force of friction also 35 Newton, and normal reaction of ground N1, this is 200 Newton. Now the ground reaction N is the resultant force of normal reaction and force of friction. Okay, so look at this, this is the 200 square plus this is the 35 whole square, this is almost 203.5 Newton. Okay, now angle made by the reaction force with the ground is this. So this is angle phi. So phi becomes, look at this, angle made by F1. So look at this here, tan inverse N1 by F1. So this is the tan inverse 200 divided by 35. Okay, understood? Next. Now ncert 7.8. A non-uniform rod of weight W is suspended by means of two strings. This string makes an angle 53.1 degree with the wall, and this string makes an angle 36.9 degree with the wall. We have to calculate the distance of center of gravity from the point A. Now we have to resolve the forces T1, T2 normal to the rod and along the rod. Now the component of T1 normal to the rod, look at this. The component of T1 normal to the rod, look at this. This is the 36.9 degree. So this also 36.9 degree. So this is the T1 cos 36.9 degree. That is 4 T1 by 5. Now the component of this is T1 sine, this is the 36.9 degree, so this is the 3 T1 divided by 5. In the same way, the component of T2, look at this, T2 cos 53.1 degree, so this is the 3 T2 by 5, and this is the, look at this, T2 sine 53.1 degree, so here T2 into sine, that is 4 by 5. Okay, now we have to consider the forces along x-axis and y-axis. Look at this, here sigma fx is equal to 0. Here 4 T2 by 5 minus 3 T1 by 5, this equal to 0. So T2 equal to, this is the 3 by 4 T1. This is equation number 1. Now look at this force plus this force minus W, this equal to 0. Here 4 T1 by 5 plus 3 T2 by 5 minus W, this equal to 0. So look at this, 4 T1 plus 3t2 equal to 5w. Okay, now put the value of t2 in this equation. So look at this, this is the 4t1 plus 3 into, this is the 3 by 4 t1 equal to 5w. Now from this condition, look at this, 4 into 4 16, 16 plus 9 25. So look at this here, 25 t1 divided by 4 equal to 5w. Here t1 equal to, this is the 20w by 25, that is, this is the 4 by 5w. Okay, this is t1 equals to 4 by 5w, so t2 equals to, look at this is the 3w by 5. Okay, now considering torque with respect to A, look at this here, w into d minus, this is the 3t2 by, this is the 3t2 by 5 into, this is the AB, this equal to 0. So look at this, WD is equal to, this is the 3 into 5, T2 equal to, look at this, 3W by 5, this is the 3W by 5 and AB equals to 2. Okay, now look at this cancel out. So look at this is the 18 by 25. So look at this is the 72 by 100. So this is the 0.72. So distance of center of gravity from A is 0.72 meter. Okay, now look at this, AB is the car and here front wheel and this is the back wheel. Now this is the front axle and this is the back axle. We have to calculate the reaction force on each wheel. Here reaction force is 2R1 and here reaction force is 2R2. Now here AB is equal to 1.8 meter and AC is equal to 1.05 meter. That is center of gravity. That is center of gravity is at a distance 1.05 meter from the front wheel, considering forces along y-axis. So look at this is the sigma Fy, this equal to 0. So this is the 2R1 plus 2R2 minus 1800 equal to 0. So look at this, R1 plus R2 equal to 900. Look at this, 2R1 and look at this, 2R1 and 2R2 are positive, 1800 negative. So this plus this minus this equal to 0. Now this equation number 1. Now considering torque with respect to A. Look at this. So look at this here, 1800 into AC minus 2R2 into AB, this equal to 0. So look at this here, 1800 into AC means 1.05 equal to 2R2 into, look at this, AB is 1.8. Okay, now R2 equal to, look at this is the 1800 into 1.05 divided by 2 into 180. Okay, now look at this and this cancel out. Now this is the 10 and this 5. So look at this is the 5 to 5. Now reaction on each back wheel is equal to 5 to 5 Newton, and in front wheel, look at this plus this equals to 900. So look at this here, R1 plus 5 to 5 equal to 900. So look at this, R1 equal to 375 kg. Okay, therefore reaction force on front wheel is 375 kg and on back wheel is 5 to 5 kg. Understood? Now next, now moment of inertia. Suppose, look at this is the axis y dash. We have to calculate the moment of inertia of the body. Okay, during our discussion on torque, we know that the moment of inertia of a particle is product of mass and square of distance from the axis of rotation. Now this body has millions of particles. So sum of moment of inertia of all the particle is equal to moment of inertia of the body. Now suppose this is the mass m1 is at a distance r1 from the axis y dash. This is the mass m2 is at a distance r2 from this axis, and here mass m3 is at a distance r3, and here mass mn is at a distance rn from the axis. Okay, so look at this, the moment of inertia of the body is equal to sum of moment of inertia of all the particles in it about this axis. So I is equal to, look at this is the m1 r1 square plus m2 r2 square plus m3 r3 square plus plus mn rn square. So look at this can be written as sigma mr square. So moment of inertia is the summation of the product of mass of the particles and their square of distance from the axis of rotation. Okay, it does not depend on mass, it depends on distribution of mass. Okay, if the mass is more scattered, moment of inertia is more. Less scattered, moment of inertia is less. The formula of moment of inertia is for discrete particle. Now for continuous distribution of mass, the moment of inertia becomes integration of r square dm. Okay, now radius of gyration. If whole mass of this body is supposed to be concentrated at a point in such a way that the moment of inertia of the body about this axis is equal to moment of inertia of the point mass, then distance of the point mass from axis of rotation is known as radius of gyration. If k be the radius of gyration, so look at this mk square, this equal to sigma mr square. Okay, so here look at this, the moment of inertia of the point mass is equal to moment of inertia of the body about the given axis. Then this is the k, the radius of gyration of the body about this axis. Okay, now we show the moment of inertia some bodies. Look at this, first of all, a rod, it mass m and length l. So look, and axis is, look at this is the normal to the length and passing through center. So here y dash be the axis, l be the length and mass of it. Its moment of inertia is 1 by 12 ml square. Now what is the radius of gyration? Look at this, mk square is equal to half ml square. So k equal to, look at this, l by 2 root 3. Okay, now ring. Look at this ring, its mass m and radius r. So look at this is a ring and its axis passing through center and normal to the plane. This is the y dash. Okay, now its moment of inertia about its axis, this is the mr square. So what is the radius of gyration? This is the r. Now disk. Now look at this disk. Look at this is the disk and its axis is passing through center normal to the plane. Look at this is the y dash. Its moment of inertia is half mr square and this is the r by root 2. Now the moment of inertia of cylinder is same as that of disk. Okay, now the cylinder is combination of disk placed one over another. Now look at this is the spherical shell or hollow sphere. Spherical shell or hollow sphere, its axis is diameter. Okay, its moment of inertia is 2 by 3 mr square and its radius of gyration root over 2 by 3 into r. Okay, now solid sphere, its mass m and radius r. So look at this here, this is the solid sphere. Okay, its axis is also diameter, okay, and its moment of inertia is 2 by 5 mr square. So radius of gyration 2 by 5 r. Now look at this. The moment of inertia of hollow sphere is 2 by 3 mr square. Moment of inertia of solid sphere 2 by 5 mr square. So look at this. The moment of inertia of hollow sphere greater than the moment of inertia of solid sphere. Okay, now triangular plate. Look at this. This is the triangular plate of height h and this is the base. So moment of inertia about base is, this is the 1 by 6 mh square. So its radius of gyration is h by root 6. Okay, understood? Now perpendicular axis theorem. Look at this. The moment of inertia about x-axis plus moment of inertia about y-axis is equal to moment of inertia about z-axis. Okay. Now perpendicular axis theorem. Suppose look at this body. We know the moment of inertia of we know the moment of inertia about this body about CG. So this is the ICG. Now we have to calculate the moment of inertia I about this axis, which is parallel to this and this, and distance of separation between the two body is d. Now here statement is I equal to, this is the ICG plus m d square. Okay, understood? Now we solve some problem related to this. Okay, look at this. The moment of inertia of disk about an axis passing through center normal to the plane is given. We have to calculate the moment of inertia about the diameter. Look at this. Suppose this is the x dash and this is the y dash. So look at this. This is the, look at this. So consider the moment of inertia of the disk about x dash is I x dash, and moment of inertia of this disk about y-axis is I y dash. Okay, now moment of inertia about x-axis plus moment of inertia about y-axis is equal to moment of inertia about z-axis, which is given here, and this is half mr square. So look at this. This is the half mr square. Now moment of inertia about x-axis is same as moment of inertia about y-axis. So look at this. This is the I x dash equal to I y dash. So look at this here. I x dash plus I x dash, this equal to half mr square. Now look at this here. I x dash equal to 1/4 mr square. Okay, understood? Now next, this is a rod of mass m and length L. So moment of inertia about an axis passing through center and normal to the length equal to 1 by 12 ml square. Now we have to calculate the moment of inertia about this axis, that is normal to the length and passing through one end. Now distance between the two axes is, this is the L by 2. So this is the D. Now if we apply the parallel axis theorem, we get, this is the I. So look at this. I equal to ICG plus MD square. Now here ICG, that is I y dash, is 1 by 12 ml square. So look at this. This is the 1 by 12 ml square, and plus here D is 12 by 2. So M into L by 2 whole square. So look at this. This is the 1 by 12 ml square plus this is the 1 by 4 ml square. So look at this. This is the ml square into 1 by 12 plus 1 by 4. So look at this. This is the 1/3. So this is the 1/3 ml square. Okay, understood? Next, now look at this. This is the ncert 7.12. This is a ring of mass capital M and radius capital R. We have to calculate the moment of inertia of this ring about the tangent. Now we know the moment of inertia of a ring about an axis normal to the plane passing through center is capital M r square. So look at this. If we consider this is the x-axis, this is the y-axis. So look at this, moment of inertia about x-axis plus moment of inertia about y-axis is equal to m r square, that is ix plus iy. This is equal to m r square. Now moment of inertia about x-axis is same as that of moment of inertia about y-axis. So here ix plus ix, this is equal to m r square. Now this is the 2ix equals to m r square. Therefore ix equals to half m r square. Now this is the moment of inertia about this axis. Now we have to calculate the moment of inertia about this axis. So look at this. If we apply the parallel axis theorem, we know the moment of inertia about CG, that is ix. We have to calculate moment of inertia about this axis. Okay, so I equal to ICG plus m d square. Now ICG means ix and m d square means this is the capital M, this is the capital M r square. So this is the half m r square plus m r square. So this is the 3 by 2 m r square is the moment of inertia of the ring about this axis. Okay, understood? Next. Now look at this 7.10. Look at this, the moment of inertia about, now the moment of inertia of a sphere about diameter is 2 by 5 m r square. We have to calculate the moment of inertia of it about tangent. Now look at this diameter is parallel to the tangent, so we apply parallel axis theorem. It equal to, this is the id plus m d square. Look at this, id is the 2 by 5 m r square plus this is the r, so this is the m r square and this is the 7 by 5 m r square. Now here id means this is the ICG, because this axis passes through the center of the sphere, that is center of the gravity. Okay, now look at this, here moment of inertia about diameter is given. Now here moment of inertia of a disc about diameter is given. We have to calculate the moment of inertia passing through tangent normal to the plane. Now look at this, here ix and iy given, so we easily calculate iz. So iz equal to ix plus iy. Now look at this, iz equal to ix plus iy. So look at this is the 1 by 4 m r square plus 1 by 4 m r square. So this is the half m r square. Now look at this, moment of inertia of this axis is known. You have to calculate moment of inertia about this axis. So you can apply the parallel axis theorem. So look at this, I dash is equal to ICG plus MD square. Now ICG means this is the IZ and D means this is the R. So here capital M R square. Look, now this is the half capital M R square plus M R square. So this is the 3 by 2 M R square. Okay, understood? Now next. Now look at this, the kinematics and dynamics of a rotational motion. Look at this, in rotational motion, for constant motion theta equal to omega into t. For accelerated motion, the final angular velocity is equal to initial angular velocity plus alpha into t. And in this case, the angular displacement theta equal to omega 1 into t, and this is the half alpha t square. And again the square of final velocity is equal to square of initial velocity plus 2 into alpha into theta. Okay, now the dynamics of rotational motion, look at this, I alpha is equal to tau. Now I alpha means this is the mk square, alpha means a by r, and this is the tau equal to f into r. So look at this, here f equal to this is the mk square by r square into a. Okay, now angular momentum. angular momentum L equal to mvr equal to I omega. Okay. Rotational kinetic energy E equal to, this is the half I omega square. Okay. Now we will be solving some numerical due to rotational kinematics and rotational dynamics. Okay. Now look at this ncert example 7.14. The angular velocity of an engine increases from 1200 rpm to 3120 rpm in 16 seconds. We have to calculate angular acceleration and number of revolution in this period. Now look at this. First of all, omega on rpm. Now rpm should be converted into radian per second. So look at this. If rpm is multiplied by 2 pi by 60, we can get radian per second. So look at this. 1200 rpm means 1200 by 60 into 1200. Now this becomes 40 radian per second. In the same way, 3120 rpm is 2 pi by 60 into 3120 radian per second, that is 104 pi radian per second. T equal to 16 second. We have to calculate alpha and theta by 2 pi, that is number of revolution. So look at this. We know omega 2 equal to omega 1 plus alpha t. So here alpha equal to omega 2 minus omega 1 divided by t. Now this is the 104 pi minus this is the 40 pi. This divided by 16. So look at this. This is the 64 pi divided by 16. So this is the 4 pi radian per second square is the angular acceleration. Now we have to calculate the number of revolution. So first of all, calculate theta. Theta equal to omega 1 into t plus this is the half alpha t square. So look at this here, omega 1. Look at this. This is the 40 pi into this is the 16 plus, look at this here, alpha into 4 pi and this is the 16 square. This is the 2 pi into 320 plus, look at this cancel out, this is the 2 pi. So 2 pi into 256. So this is the 2 pi into this is the 576. Therefore, number of revolution theta by 2 pi is 576. Okay, understood? Now next. Now look at this. This is a flywheel. It is mounted by a horizontal axis. A cord is wound on it and force equal to 25 Newton acting on it. The mass of the flywheel is 20 kg and radius is 0.2 meter. We have to calculate angular acceleration and work done for the pulling of the rope by 10 meter and increase of kinetic energy. Now to calculate the acceleration, we have to use the torque equation. Now torque tau equal to this is the I into alpha. Now torque tau equal to force into r. This is the half m. Now this is the moment of inertia. The moment of inertia of the flywheel, this is the half capital M r square into alpha. So look at this here, F equal to 25 Newton, R equal to 0.2 and this is the half, M is the 20 kg and this is the 0.2 whole square and this is the alpha. Now look at this. So this is equal to, look at this, this is the 5 and this is the 10. So this is the 0.4 into alpha. Therefore alpha equals to 5 by 0.4. So this is the 12.5 radian per second square. Okay, understood? Now next, work done, the pulling the rope by 10 meter. So look at this, work done by pulling the rope is W equals to F into S. So this is the 25 into 10. So this is the 250 joule is the work done. Now increase of kinetic energy. Now look at this, the angle of rotation for 10 meter is S by R. Now this is the 10 meter and radius is 0.2. Okay, so look at this is the 50 radian is the angle of rotation. Now we have to calculate the angular velocity. Look at this, omega 2 square equal to omega 1 square, that is 0 square plus 2 alpha theta. Now look at this, 2 into where alpha, look at this, alpha is 12.5, so this is the 12.5 and this is the 50. So look at this is the 25 into 50. Okay, now kinetic energy equals to half into I into omega square. Now I equal to half mr square, so this is the half into capital M r square into omega square. This is the 1 by 4 into 20 into 0.2 whole square into 25 into 50. Okay, now look at this and this is the 5. So look at this 5 in, now look at this is the 5 into 25 into 50 into 0.04. Okay, now look at this and this equal to 1, so this is the 250 joule. Okay, so look at this, the increase of kinetic energy and work done are same, so work done is converted into kinetic energy. Understood? Next, now look at this, ncert is 7.11. Equal torque applied on a hollow cylinder and a solid sphere, which one has greater angular velocity after a given time. Now angular acceleration of hollow cylinder, this is the tau by I1, that is the tau by mr square. Now angular acceleration of solid sphere, this is the tau by 2 by 5 mr square. So look at this is the 5 tau by 2 mr square. So look at this is the 5 by 2 into alpha 1. So look at this, the angular acceleration of solid sphere is 5 by 2 times greater than angular acceleration of the hollow cylinder. Therefore, for a given time, the angular velocity of solid sphere is more than the angular velocity of the hollow cylinder. Okay, look at this. Now ncert is 7.12. A solid cylinder of mass 20 kg and radius 0.25 meter rotates with angular velocity 100 radian per second. We have to calculate kinetic energy and angular momentum. Now look at this. So here moment of inertia, that is half mr square, mass is 20 kg, r is 0.25, so we get 5 by 8 kg meter square. So look at this, here kinetic energy, this is the half into I, that is 5 by 8, and this is the 100 square, so this is the 100 square. So look at this is the 5 by 2 into 8 into 100 into 100. Okay, now this and this is the 25 2, and this is the 25. So look at this, 6 to 5 into 5, so this is the 3125 joule is the kinetic energy. Now angular momentum, look at this, angular momentum, this is the 5 by 8 and this is the 100. Okay, now this and this is cancel out, so this is the 25 by 2 and this is the 1 to 5 by 2, so this is the 62.5, this is the joule second. Okay, understood? Next, a rope of negligible mass wound on a hollow cylinder of mass 3 kg, radius 0.4 meter. A force of 30 Newton acting on the rope. We have to calculate angular acceleration. Now to calculate acceleration, we have to apply torque equation. So look at this, tau equal to I alpha. Now tau equal to F into R, the equal to I alpha. I means 0.48, so 0.48 into alpha. Look at this is the 30 and R is equal to 0.4. So look at this is the 0.40 and this is the 0.48 into alpha. So alpha equal, look at this, 30 into 0.40 by 0.48. So look at this is the 1200 divided by 48. Now look at this is the 4 and this is the 100. So this is the 25 radian per second square is the angular acceleration of the hollow cylinder. Okay, next. Now look at this. To maintain the constant angular velocity of a rotor, the torque applied is 180 Newton meter. We have to calculate power required. Now power P equal to, this is the tau into omega. So this is the 180 into 200 watt. So this is the 36000 watt. Okay, understood? Now next, look at this. A body of radius r moves with velocity v. If angular velocity of the body is omega and v equal to omega r is fulfilled, then its motion is called pure rolling. In pure rolling, the force of friction helps the body to roll. Okay, now if v naught be the initial linear velocity and omega naught be the initial angular velocity, then look at this, the retardation takes place. So here v equal to v naught minus 80 and here omega equal to, this is the omega naught plus alpha into t into r. Now look at this, here retardation produced by force of friction. So here look at this, v naught minus, this is the f by m into t, and here look at this, omega naught plus tau by I into t. Look at this, here alpha equal to tau by I. So here omega naught plus tau by I into t into r. From this equation we can calculate the time during which pure rolling start. Now in pure rolling, distance travel in one complete rotation is equal to 2 pi r. The numerical of pure rolling can also be solved with the help of the conservation of angular momentum. Look at this, in this case here I1 omega naught plus this is the m v naught r equal to, look at this, here I2 omega plus this is the mvr. Okay, here v equal to omega r. Now this formula also help us to get the final velocity v during pure rolling. Okay, understood? Again, if v greater than omega r, then it is called rolling with forward sliding, and if v less than omega r, it is called rolling with backward sliding. Okay, now we will be solving some numerical related to pure rolling. Okay, now look at this ncert numerical 7.30. The radius of a disc and ring are both 0.1 meter and coefficient of kinetic friction is 0.2 between the ground and ring or disc. So force of friction, this is the mu k mg. So mu k is 0.2 into m and g is the 10. So force of friction is the 2m. Initial angular velocity is 10 pi. We have to calculate which one start pure rolling earlier, ring or disc. Now first of all consider a ring. Now moment of inertia of ring is I equal to mr square. So angular acceleration is tau by I. Now tau equal to force of friction into r divided by I. So look at this, alpha equal to, now force of friction is equal to 2m. So this is the 2m into r divided by I equal to mr square. So this is the mr square. So here mm cancel out, r cancel out. So this is the 2 by r. Now r is the 0.1. So 2 by 0.1, that is 20 radian per second square. Okay, now look at this. Here the condition is v equal to omega r is the condition of pure rolling. Now this angular velocity omega naught decreases to omega and linear velocity decreases from 0 to v. So look at this, here 0 plus this is the acceleration a into t equal to this is the omega naught minus alpha into t into r. Okay, understood? Now look at this, here acceleration equal to force by friction divided by m. So look at this, here 2m divided by m into t equal to omega naught, that is 10 pi into r minus alpha into r into t. Okay, now this is the 10 pi into 0.1, alpha is the 20, r is 0.1 into t. So look at this is the 2t equal to pi minus 2t. So look at this, here 4t equal to pi, therefore t equal to pi by 4. Okay, understood? In case of disk, look at this, the moment of inertia is half mr square. So look at this, here this is the half mr square. So here look at this is the 2 by r, so this is the 2, so this is the 40 angular acceleration. Okay, now look at this, v equal to omega r. Now this is the v omega r. Now alpha, look at this, here alpha is equal to 40. Okay, now from this equation we can get this is the 4. If this is the 4, then this is the 6. So t equal to this is the pi by 6. So the disk starts pure rolling in pi by 6 second, while ring starts pure rolling in pi by 4 second. So disk starts pure rolling earlier than ring. Okay, understood? Next, now look at this, a spherical shell is given a horizontal velocity v on a rough horizontal surface. Find velocity when pure rolling start, time after which pure rolling start, distance traveled before pure rolling start, and work done by the friction. Okay, now look at this, we solve this problem one by one. Okay, so look at this, here look at this, here initial velocity v along this direction. So initial angular velocity omega naught is equal to 0. Okay, now we have to calculate the time after which pure rolling start. So look at this, here v dash is equal to omega r. Okay, now here v decreases due to force of friction. So look at this, here v minus at is equal to omega, this is the omega naught plus alpha into t, this is the r. Okay, now here F equal to this is the force of friction mu mg by m into t. Here omega naught equal to 0. Now tau is the force of friction into r divided by moment of inertia of the spherical shell 2 by 3 mr square into t whole divided by r. Okay, look at this, here m cancel out. Okay, so look at this, here v minus mu g t equal to, look at now this is the mu mg r t into 3 divided by 2 mr square into r. Now look at this, r square cancel out, m cancel out. Okay, so we get, look at this is the 3 mu g t by 2 and here v minus mu g t. So look at this, v equals to this is the 5 by 2 mu g t. So here t equal to this is the 2v divided by 5 mu g is the time after which pure rolling starts. Okay, now we have to calculate velocity when pure rolling start. So look at this, here v dash equal to v minus at A means mu g and T means this is the 2V by 5 mu g. So look at this is the V minus 2V by 5. So this is the 3V by 5 is the velocity when pure rolling start. Okay. Now distance covered before pure rolling start. Okay. Look at this. This is the final velocity 3V by 5 whole square equal to initial velocity v square minus 2 acceleration means mu g into s. Now look at this. This is the 2 mu g s. This is the v square minus this is the 9 v square by 25. So this is the 16 v square by 25. Therefore s equals to 8 v square divided by 25 mu g. Okay, is the distance covered before pure rolling start. And last problem work done by the friction. Okay, now look at this. The initial kinetic energy half mv square plus work done by the friction is equal to final kinetic energy. Now final kinetic energy means this is the translational kinetic energy. Half m is the half m into 3v by 5 whole square plus rotational kinetic energy. This is the half I. If linear velocity is 3v by 5, so angular velocity is 3v by 5r. So this is the 3v by 5r whole square. Okay, here delta w, this equal to half mv square into 9 by 25 plus, look at this, here half into this is the 2 by 3 mr square into 9 by 25 v square by r square. Now r square cancel out. Okay, now look at this cancel out, this and these 3. Okay, minus half mv square. Okay, so look at this. This is the half. Look at this. This is the half mv square. Here 9 by 25 plus, look at this, here 3 by 25. So look at this, here 6 by 25 minus mv square, minus 1. Now look at this is the half mv square. This equal to, this is the 15 by 25 minus 1. So look at this is the half mv square. This is the 10 by 25. So this is the minus 1 by 5 mv square. Now kinetic energy during pure rolling. In pure rolling, the total Ke is equal to Ke of translation plus Ke of rotation plus Ke of rotation. Okay. Now look at this, Ke of translation, this is the half mv square, and Ke of rotation, this is the half I omega square. So look at this is the half mv square plus this is the half mk square into v square by r square. Okay, so look at this is the half mv square into 1 plus k square by r square. So total kinetic energy depends on radius of gyration. So total kinetic energy of different body are different. Okay, now look at this, a hoop of moment of inertia mr square, mass 100 kg, radius 2 meter, rolls with velocity 0.2 meter per second. We have to calculate the work done to stop it. The work done to stop it is equal to change of kinetic energy. So work done is equal to, this is the half mv square plus half I omega square. Now this becomes half mv square into 1 plus k square by r square. Now look at this, its moment of inertia is mr square. So mr square equal to mk square. So k square by r square equal to 1. So look at this is the half mv square into 1 plus 1. So look at this is the half mv square into 2. Now here m equal to, look at this, 100 kg and v equal to 0.2 whole square. So look at this, this is the 100 into 0.04. So this is the 4 joule. Therefore work done is equal to 4 joule. Okay, understood? Now look at this, a body rolls down an inclined plane of height h. We have to calculate velocity at the bottom point of an inclined plane. So look at this, here potential energy of the body is converted into kinetic energy. Now kinetic energy of rolling, this is the half mv square into 1 plus k square by r square, where k is the radius of gyration of the body. So this kinetic energy is obtained from the mechanical energy. So this is the mgh. Therefore v square equal to, look at this, 2gh divided by 1 plus k square by r square. Okay, understood? Next. Now acceleration rolling down an inclined plane. Now when a body on an inclined plane, the force of friction small f acting tangentially and provide torque for its rotational motion. So look at this, the torque tau is equal to, this is the f into r, this equal to I into alpha. So look at this, here f into r, this equal to mk square and alpha is equal to a by r. So look at this, the force of friction F equals to, this is the mk square by r square into a. Now here mg sin theta acting along the plane and here force of friction up the plane. So look at this, the resultant force mg sin theta minus small f, this equal to mass into acceleration. Now put the value of f here. So here mg sin theta minus mk square by r square into a, this is ma. Therefore mg sin theta, this equal to m a into 1 plus k square by r square. Okay, now m cancel out, so a equal to, this is the g sin theta divided by 1 plus k square by r square is the acceleration rolls down an inclined plane, and here f is the force of friction acting on the body up the plane. Okay, look at this, there are two inclined plane, here angle of inclination more, here angle of inclination less. A sphere rolls down these two inclined plane. Now the question is, in which plane the sphere reach the bottom with more velocity, and in which plane the sphere takes smaller time to reach the bottom. Okay, now look at this, here acceleration a is equal to, this is the g sin theta divided by 1 plus k square by r square. Here a directly proportional to sin theta, so greater the value of theta, greater the acceleration. So here acceleration a1 greater than a2. So velocity at the bottom in this case is more and here is less. Now time to reach the bottom. Look at this, time t equal to, this is the root under 2s by a. So t is inversely proportional to square root of 1 by a. So look at this, here more acceleration, so it takes less time to reach the bottom, and here takes more time to reach the bottom. Okay, understood? Next, look at this. Now look at this, a cylinder rolls up the inclined plane of inclination 30 degree. Find what distance it covered. And next, after what time the cylinder again comes back to this point. Now first case, look at this, here total kinetic energy of rolling is equal to increase of potential energy. Suppose cylinder reaches this point. So look at this, this is the height. Now we have to calculate the height. Now here mgh is equal to total k, that is half mv square plus 1 plus k square by r square. Now the moment of inertia of cylinder is half mr square. So half mr square equal to mk square. Therefore k square by r square equal to half. Therefore look at this here, mgh, this equal to half mv square into 1 plus half. So look at this and this cancel out. This is the 10 into h and this is the half into, look at this here, v equal to 5 meter per second. So look at this is the 3 by 2. So h equal to, look at this is the 25 into 3 divided by 40. Look at this is the 5 and this is the 8. So this is the 15 by 8. Okay, understood? Now distance covered. Look at this. If s be the distance along the plane, then look at this, h by s, this equal to sine theta. Therefore as theta 30 degree, so this is the half. Therefore s equals to 2h. Therefore distance covered s equals to, this is the 15 into 8 into 2. So this is the 15 by 4, that is 3.75 meter along the plane. Okay, so distance ascent is equal to 3.75 meter. Now we have to calculate time required to again come back this point. So here time of ascent plus here time of descent. Now we have to calculate time of descent and then multiplied by 2 we get total time of elapse. So look at this. Here s equal to half a t square. Now we have to calculate acceleration. Look at this here, a equal to, this is the g sin theta, that is sin 30 degree, divided by 1 plus k square by r square. Look at this, k square by r square is half, so this is the half. So look at this is the 5 divided by 3 by 2, so this is the 10 by 3. So here time t equal to, look at this, time t equal to, this is the 2s by a. Now look at this here, 2 into, this is the 3.75 divided by a is the 10 by 3. Now this is the 6 into 3.75 divided by 10. Okay, this is the 6 into 375 divided by 1000. Okay, now if we divide by 25, look at this is the 15 and this is the 40. Okay, this is the 90 and this is the 40, this. So this is the 3 by 2. So look at this, the time of descent from this position to this is 3 by 2. So time of ascent is also 3 by 2. Therefore total time to reach again at this point is, this is the 3 by 2 into 2, that is 3 seconds. Okay, understood? Next, look at this, a sphere rolls down an inclined plane of inclination 30 degree. Here theta equal to 30 degree. Now we have to calculate force of friction acting on the cylinder. Now first of all we have to calculate the acceleration. Look at this, acceleration is equal to, this is the g sin theta divided by 1 plus k square by r square. Look at this, for cylinder k square by r square equal to half. So look at this is the 10 into half divided by 1 plus half. So look at this is the 10 by 2 and this is the 3 by 2. So this is the 10 by 3 meter per second square is the acceleration of the cylinder. Now force of friction, look at this, for torque equation F into R, this is the I alpha. Now I equals to, this is the half mr square and alpha equals to A by R. Okay, look at this here, F equal to, so this is the half ma. Now here half m is the 10 kg and a is the 10 by 3. So look at this is the 50 by 3. So this is the 16.7 Newton is the force of friction. Okay, now work done against the friction. Look at this, friction helps to roll a body, so work done by the friction is equal to 0. Okay, now look at this, theta max for pure rolling. Look at this, for pure rolling the torque is equal to I alpha. Okay, now this is the F into R, and this is the half mr square, and this is the A by R. Okay, look at this. F equals to, this is the mu mg cos theta. Now into R, and this is the half mar. Now R cancel out. Okay, now look at this. Here also cancel out. So look at this, mu g cos theta, this equal to half into A means this is the g sin theta divided by 1 plus k square by r square. Okay, now look at this. Here g and g cancel out. Okay, now here mu equal to 1 by 4, this is the cos theta equal to half into sin theta, and look at this, this is the 1 plus half. Okay, for cylinder k square by r square equal to half. So look at this, this is the 1 by 4 cos theta, and this is the half into sin theta divided by 3 by 2. Now this cancel out. So look at this, here sin theta divided by cos theta, this is the 3 by 4. So tan theta, this is the 3 by 4, this is the tan 37 degree. Therefore theta equal to 37 degree. The angle up to which pure rolling exists, this is the 37 degree. Okay, understood? Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, Main and Advanced. Please like, share and comment on this. And if you are new, don't forget to subscribe my channel to get the clear concept of physics. Okay?